Hello everyone. So we are going to discuss on the topic of impact of jet stream on Indian monsoon. Okay. In the previous session of Coriolis force, we have discussed about impact of Coriolis forces on different wind circulation, whether it be advection currents or the surface winds, or they could be geostrophic winds. These geostrophic winds are said to be jet stream. Jet streams are basically upper atmospheric fast moving winds moving from west to east direction. They are basically of two types. Permanent jet stream. The permanent jet streams are of two types. Further, they can be classified into two types. Subtropical jet stream, the upper tropospheric winds that are moving from subtropical region from west to east direction. And the polar jet stream that are moving in the subpolar and polar region from west to east direction. And there are some temporary jet stream as well. Since I have been asked to discuss on the topic of impact of jet stream on Indian monsoon, so we would be directly jumping into the topic. Okay. Otherwise, this is the live illustration of jet stream. This is polar jet and this is subtropical jet. Now, directly coming to the topic, what is the impact of jet stream on monsoon of India? Okay. So we know monsoon as per the dynamic theory of form. It is because of the dynamicity of the pressure belts. How dynamic are the pressure belts? During the summer solstice, when the sun rays directly fall over the northern hemisphere, somewhere near June, okay, the ITCZ, intertropical convergence zone, okay, it is actually a locus of low pressure. It shifts from equator towards the northern plains of India. As a result, the subtropical high pressure belt 30-degree, okay, it is over the Madagascar, which is also known as Mascarene High. It is located in the southern hemisphere beneath the equator. As we know, the advection currents, the wind moves from high pressure to low pressure. The winds are moving in southern hemisphere. They are tilting towards left hand side because of the Coriolis force. As soon as they crosses equator, the winds approaches India towards the low pressure of ITCZ. Okay, and these winds, if you look at the tail of these winds, I'll draw it here. They are originating from western and southern direction. So these winds are said to be southwest monsoon winds. It has two further branches, the Arabian Sea branch and Bay of Bengal branch. Okay, they approach Indian subcontinent, and during the first week of June, they enters the Shion Pass of Kerala, which is known as the gateway to of southwest monsoon, and brings rainfall in India. As the summer season passes, somewhere near October, when the ITCZ starts descending down, the subtropical high pressure belt, which is established somewhere near Delhi, near the Himalayas, the high pressure belt or the subtropical high pressure belt releases trade winds. Okay, these trade winds, I'll draw it in a different color, purple color. These trade winds are said to be northeast trade winds. They gain moisture from Bay of Bengal branch and brings rainfall to the Coromandel coast of India. This was a brief about monsoon. Monsoon itself means reversal of winds. We get monsoon from southwest monsoon winds and northeast trade winds. Now the big question arises that what is the impact of jet stream? Now directly coming to the topic. Actually what happens, we know this is Mediterranean Sea. Subtropical jet stream during winter season is flowing over the Indian peninsula. Okay. Due to the height of Himalayas, it gets divided into two parts. The southern part, the subtropical jet, they are trapped by the mighty Himalayas. We know jet streams are upper tropospheric winds approximately 6 to 8 kilometers of height, and Himalayas, the highest peak is 8851 kilometers height, named as Mount Everest. So it traps the jet stream. And how the jet stream, why only they flow in winter season? Because in winter season, what happens? The ITCZ descend downs, we know that the pressure belts are dynamic. So with the dynamicity of these pressure belts, the subtropical high pressure belt, it also descend downs. Along with that, The subtropical jet stream also descends down and strikes the northern part of India. Not only this, not only this, what does this jet stream do? During the winter season, they gain moisture. I'll use a different color. They gain moisture from Mediterranean Sea. They gain moisture from Black Sea. They gain moisture from some parts of Caspian Sea. Okay, and they bring direct rainfall to the northern part of India, especially Punjab, Haryana, northern Rajasthan, western UP. They are known as western disturbance. They are known as western disturbance. All right. Okay. Now these western disturbance, they bring rainfall for India. Okay, they are very good for rabi crops, especially wheat, but not good for cotton crops like but not good for kharif crops like cotton, as they destroy the cotton balls. Now, what is the impact of jet stream? Coming directly to the asked topic. These jet stream, what they do, technically, after March, the sun rays starts directly falling over the northern hemisphere. But there is a big question regarding Indian monsoon. March, April, May, June. Why these 3 months of delay is there? Delay for what? ITCZ, since ITCZ is the locus of low pressure, and low pressure is formed due to the thermal factors. What are the thermal factors? This low pressure is formed wherever there is the incidence of the sun rays. Since the sun rays from the late of March, they start directly striking the northern plains of India. Why the ITCZ is not formed over the Indian peninsula just after March? Why there is a delay of these 3 months? The answer here is jet stream. When the winter is over, okay, the subtropical jet stream moves up due to the dynamicity of pressure belts. The ITCZ also approaches the northern hemisphere, but ITCZ comes and the ITCZ is blocked from entering India. Why? Because a part of subtropical jet stream, a part of jet stream is trapped by the mighty Himalayas. The Himalayas have trapped these jet stream, and as a result, what does a jet stream denotes? Jet streams, they came to India in the winter season. So in the winter season, they denotes high pressure. So this high pressure is repelling the ITCZ's low pressure. Are you getting my point? The ITCZ's low pressure is not able to approach the northern plains. And until and unless the ITCZ is established over the northern plains of India, there cannot be monsoon. So what is the phenomena? What is the phenomena because of which the trapped subtropical jet stream is pushed over the Himalayas? When this subtropical jet stream is pushed over the Himalayas, when it moves upward, the ITCZ comfortably establishes itself over the northern plains and monsoon is brought into the India. The answer here is role of Tibetan Plateau. Okay. I will show, see, this is the top view. This is the top view what we are seeing. Now what I will show you the front view of the jet stream. Let's just imagine how could the front view look like. These are the ranges of Himalayas. These are the northern plains, Indian Peninsula, 0 degree equator, and this is Madagascar. Okay, this is Madagascar. This is Himalayas. This is Tibetan Plateau. I guess I am hiding something. Okay, I'll just recorrect it once. This is Tibetan Plateau. These are the mighty Himalayas. Okay, this is the northern plains, Indian Peninsula, uplifted Indian Peninsula, 0 degree, and this is Madagascar. Okay, this is Madagascar here. Okay, I'm just showing you the front view. Now just try to imagine. Just try to imagine. ITCZ is somewhere here. It cannot. This is northern plains. This part is northern plains. ITCZ is not able to climb over this northern plains. Why? Because what's happening here? Because subtropical jet stream is trapped by the Himalayas. Now, what is the role of Tibetan plateau? Post March, okay, after March, when intense sun rays are hitting the Tibetan plateau. And what this Tibetan plateau is made up of amphibaric rock structure, or granitic rock structure. Now, what's happening here? Due to the intense heating, strong low pressure is formed over the Tibetan plateau. It releases very strong convectional currents. These strong convectional currents, okay, when they strike the jet stream, they push the jet stream. As soon as the jet stream is lifted above the height of Himalayas, the jet stream quickly moves over Himalayas, just like this. Okay, just see this diagram. Here, Tibetan plateau is hitting the jet stream. Okay, jet stream is pushed over the uh, uh, Tibetan plateau is hitting the jet stream. Now the new jet stream is pushed over the Himalayas. As soon as the jet stream moves over the Himalayas, the ITCZ establishes itself over the northern plains, and this approximately takes 3 months. This approximately takes 3 months from March to May, and technically near first week of June, the southwest monsoon rises. This is the role of Tibetan plateau. Another role of jet stream. Okay, so this was the role of subtropical jet stream. Now there is one more jet stream. Okay, its name is tropical easterly jet, TEJ. What is the role of this tropical easterly jets? Let's first understand. Okay. See, there is always, just remember the Ferrel cell. We have read about Ferrel cell, we have read about Hadley cell. Okay, there is always upper atmospheric circulation. So what is happening here? Okay, here we have high pressure. Okay, here we have low pressure. Low pressure of Tibetan plateau, northern plains, and ITCZ is there as well. This is the upper atmospheric circulation. It is coming to the high pressure of Madagascar. The air is descending down, and again the surface winds of southwest monsoon are moving like this. Southwest monsoon, this dotted circulation is upper air circulation, and this upper air circulation from the peninsula of India, that is descending air near the coast of Africa, near the Madagascar, it is tropical easterly jet. Now let's imagine the situation. If there is very strong heating of Tibetan plateau, there would be strong convection currents. If the convection currents are very strong, the tropical easterly jet would be very strong, and there would be high descending of air over the Madagascar. So it will eventually strengthen the high pressure over the Madagascar. If the high pressure of Madagascar is strengthened, then the pressure gradient force between Indian Peninsula and Madagascar would be very strong. That would eventually lead to strong southwest monsoon. Okay, so it is another role of tropical easterly jet, which is a temporary jet stream over the Indian Peninsula. Okay, I hope it's clear. It is somewhat like this. If I show you the front view, it is somewhat like this. Low pressure. Okay, this is Madagascar. This is southwest monsoon. This is southwest monsoon. This is tropical easterly jet. Okay, this is high pressure of Madagascar, and this is convection currents of Tibetan plateau and or an ITCZ of India. Okay, this circulation, this circulation is known as monsoon circulation. Okay, another jet stream, it is known as, that originates from the coast of Somalia. It is also a temporary jet stream. It also impacts Indian monsoon. But for that, we need to first understand the various other phenomena. What are the other phenomena like Indian Ocean Dipole, El Nino? Okay, what is El Nino? El Nino Modoki. What is La Nina Modoki? Okay, what is the role of Walker cell, reversal of Walker cell, eastward shifting of Walker cell? Okay, what is ENSO, El Nino southern oxidation? This, with these phenomena, we would completely understand the phenomena of jet stream. Okay, the phenomena of Indian monsoon. Why there is delay? Okay, since sir has asked me to prepare the lecture on jet stream and its impact of Indian monsoon, so I am directly making the lecture on that. Okay, if needed, I can also make the lecture on what is jet stream, what is the phenomena of jet stream. Thank you so much.